Hi, my name is Mark, and in this video I'm going to showcase our Rodent Langendorff system. I will be highlighting the components of the system as well as the hardware setup for acquisition. I will also demonstrate how to prime the system and then end off with the calibration of flow. So we'll start off with the main stand, which consists of a stainless steel base and these stainless steel support rods. The support rods screw into the base like so. And the system also consists of a handy spill tray for overflowing perfusate, which you can then run off to the drain. The next component is the perfusate reservoir, which, as the name suggests, holds the perfusate. The system allows for 2 of these in case you want to swap between perfusates or if you have a high flow application. The reservoir is water jacketed, which allows through the inlet port and outlet port warm water to surround the perfusate to keep it at the correct temperature. And it also has an output port for the perfusate to supply to the system. Now, the system comes with these clamps, which I'll demonstrate how to attach this. So you just turn this and attach the clamp, and then you can attach it to the system using the stand clamps. Like so. The next component is the gas bubblers. This supplies carbox to the perfusate. So the gas inlet is over there. This is an overflow inlet, and it consists of a glass frit at the bottom which produces really small bubbles. So we can just place this inside the perfusate reservoir for the one and for the other. To supply the carbox or oxygen to the perfusate, we have this manifold, gas manifold, which we can place using the clamp with the yellow screw, which is a Teflon screw. And this manifold consists of needle valves, Teflon needle valves, so you can adjust the flow of oxygen to each of the perfusate reservoirs. The next part is the perfusion core, which is actually at the heart of the whole system. So it consists of a water jacketed chamber, like all the other glassware pieces. It has an inlet port and an outlet port. This is to keep the perfusate at the correct temperature. So the perfusate comes in through this port, goes around a coil to be reheated by the water jacketing. And then at the top there is a bubble trap. This is to remove any bubbles which may form before it goes down into the heart. On top of the bubble trap there is a port for a damping syringe to dampen any oscillations from the pump. And the bubble trap also has a overflow port, which is this one over here. Down at the bottom we have 4 access ports, and these ports can be fitted with either a lure fitting, such as this one, which we can just add in to one of these. And this is to attach things like a pressure transducer. We also have these little rubber septa, which you can put into one of these caps too. And this is ideal for applying a drug through a syringe. So you can put the needle through the septa to apply the drug. At the bottom here, this is the lid for the heart chamber, which is already been attached over this glass sheath. And this is where the actual heart chamber will screw into. So the last glassware component is the heart chamber, which is water jacketed. It has an input and an output port, and this is to keep the heart warm. It also has a port for a pulley system in case you want to do apical force measurements. It has this adapter at the bottom which you can just attach to connect any 2-way or 3-way taps And then I can just attach this to the system using the clamps. And then I can tighten the lid around, and this will keep the heart nice and warm. Next, I'll show the water jacketed circuit. So it comes from the heated water circulator. First goes into the heart chamber, fills up the heart chamber. Then from the heart chamber, it will go to the perfusion core, fill up the perfusion core. And from the perfusion core, it will go through a wire adapter to the bottom ports of the perfusate reservoirs. These will fill up, and then again through a wire adapter back to the water or heated water circulator. As a tip, if it is difficult to fit the tubing to the ports, a good little tip is to just dip it in some water, and then you'll see it'll slide in quite easily, and then you can fasten. Next, we'll be looking at the gas circuit. I have removed all the water jacketing just for clarity. So the one side will connect to a gas tank through a regulator. This will go through the manifold to each of the input ports on the oxygen bubblers. The manifold also has some valves by which you can regulate or fine regulate the gas supply to the perfusate. Next, we will be looking at the perfusate pathway. So the perfusate will come from the output ports of the perfusate reservoirs. Both will be going into a three-way tap where you can select the perfusate to come from both reservoirs or just a single one. It'll go through the pump and back up to the perfusion core, where it'll go through the coil and up to the bubble trap. When we're priming the system, the overflow over here will be open, and the perfusate can then run off back into the perfusate reservoirs through the input ports of the gas bubblers. When this system is in operation, the overflow will be closed, forcing the perfusate down into the aortic cannula. And we've also added the damping syringe, which we can control also with a stopcock. Next, we'll be looking at setting up the hardware to measure and control the pressure and flow in the system. For this, we need a PowerLab C, the STH pump controller, and the bridge amp. If you would like to record other parameters like ECG or left ventricular developed pressure, you're going to require additional hardware. To measure the pressure, the perfusate pressure, we require a physiological pressure transducer, and this is connected to one of the 4 ports so that it's as close as possible to the heart. And this pressure transducer is then connected to the bridge amp. And if you need to know how to calibrate the pressure transducer, we have some videos on our website. For the connections on the back of the units, we first connect a BNC T-piece to the output of the bridge amp. One side will go to the pressure input on the STH pump controller. Then to interface the bridge amp to the PowerLab C, we will use the front end interface. This will in turn connect to the PowerLab C through the USB-C ports and also on this input port on the PowerLab C. And the analog cable, we will connect the red connector to the other side of the BNC T-piece. For clarity, I have removed the front-end interface from the bridge amp. So to connect the STH pump controller to the PowerLab C, we connect a front-end interface to the STH pump controller. Next, I'll connect the analog cable and the red connector to flow output on the STH pump controller. And finally, I connect the USB-C cable to the other input on the PowerLab C. Once the setup is complete, all we need to do is connect the peristaltic pump to the STH pump controller, and we use the supplied interface cable from the pump to the STH pump controller. And now the system is ready for priming. So next we start the pump. Make sure you use enough or sufficient flow. We use 85 RPM on this pump. You'll see the coil is filling up and so is the bubble trap. As soon as it hits the overflow, it will flow back to the reservoir. Once this happens, we can close off the overflow and open up the cannula. Now, to prime the transducer, we're going to close the cannula, open and close the port to the transducer, and then open the cannula again, just to get rid of any bubbles inside the transducer. So I'll do that now. We'll close this, open, close, and then open the... So now the transducer is primed. If there are still any more bubbles in there, then you can do the same again. Close, open this, close, and open the cannula again. Now you see there are no bubbles inside those ports. Once the system is fully primed, we can switch off the pump and close the tap to the cannula so that we don't have any leakages. So to calibrate for flow, first thing I'll do is set the pump to external. This is so that it can be controlled by the STH pump controller. Next, I set the flow all the way to 0 by turning this knob all the way counterclockwise. And then I can hit run. So now the pump is on 0, it's not running at all. And then I can set the pump speed to, for example, in our case, set it to 10 RPM. And now I can time, as soon as I put this measuring cylinder under the cannula, I can time for exactly 1 minute. And this will give us the flow rate, or one of the values of our flow rate. Now, once the pump has run at a constant speed for exactly 1 minute, the measuring cylinder, in this case, ends up being filled to 11 milliliters. This translates to a flow of 11 milliliters per minute. So now we have two known points for calibration, 0 and 11. In LabChart Lightning, we go to the channel where the flow output of the STH pump controller is connected to, and select the data where the pump goes from 0 to 11. We then select channel, the units, and for the 0 level, we set that as 0.1, that is 0, and then for where it's a constant, set that as 0.2, and that will be 11, with the units being milliliters per minute. Once we apply this, we now have the units for the flow channel in milliliters per minute. Thank you for watching this video. Should you require more information on the system, please contact your nearest support or sales representative.